Hello, in this video we are going to learn about mass, weight and density, but to start with we're going to concentrate on learning about the difference between mass and weight. First of all, let's explain what mass is. Mass is defined as the quantity of matter in an object. Mass is usually measured in kilogram, which is the SI unit, and it is measured using a top band balance or a beam balance. Now, mass always remains constant and does not depend or vary with position on the Earth's surface. A body's mass influences its ability to change in motion or state of rest. Now, when we say this, it makes us to begin to think about inertia. Now, inertia is defined as a state of rest or a state of uniform motion. Bodies with larger masses develop more inertia than those with smaller masses. This explains why it takes more time for a lorry to stop after the driver applies the brakes compared to a smaller car. Now, what about weight? Now, weight is the pull of gravity on an object. It is measured in Newton using a spring balance. A spring balance is also called force meter or Newton meter. Weight varies from place to place on the Earth's surface. This means that the weight of an object, when measured near the equator, may be slightly different with what its weight would be at the poles. Now, this variation results from the fact that the Earth is not a uniform sphere. Now, normally, apart from the fact that weight can be measured, we can also get weight by calculation. To calculate weight, we need to use the formula weight is equal to mass times acceleration due to gravity g. The acceleration due to gravity g is measured in meters per second squared. If we use the symbol W for weight, M for mass, and G for acceleration, then W is equal to mg, and the SI unit for W, which is actually weight, is Newton. Now, to see this, first of all, it's important to know that, as we said, that acceleration due to gravity is approximately equal to 9.8. Now, the value 9.8 can be rounded off to 10, and we can be able to say that acceleration due to gravity is 10 meters per second. Likewise, we can think of acceleration due to gravity to be related to the gravitational field strength. And the same value, 10, can be used, but in this case, we are going to talk about it in terms of Newton per kilogram. So that the gravitational field strength is actually measured in Newton per kilogram. If we bring back our formula, W is equal to mg, or m times g, and we replace m with kg for the mass, which is the SI unit for mass, and g with Newton per kilogram, n over kg, then we can cancel kg with kg and we are left with Newton. An example is where we have, if we are given 20 kilogram to be the mass of a given object, and the acceleration due to gravity g given to us as 10 Newton per kilogram, then W becomes 20 times 10, which gives us 200 Newton. Another case, another example, if we are given that the weight of an object is 500 Newton and we have been asked to calculate mass, then we say that W is equal to mg. That means m is equal to W over g. Now, since g is always known to be roughly 10 Newton per kilogram, we will take 500 Newton, we divide by 10 Newton per kilogram, and if we follow the mathematics rules, this kg will go up and we'll end up with 50 kilogram, because we'll end up with 50 kilogram because Newton and Newton will cancel and we'll be left with the kg, which will actually go up. Now let's talk about density. Density is defined by a formula. Density is equal to mass divided by the volume of a given object. Now, what that means is that the density of an object, which is symbolized as rho, given by m over v, where m is the mass and v is the volume of the object, and that m is usually measured in kilogram and v is measured in meters cubed or grams and centimeters cubed. When we think about density, what we are saying is, what is the spread or what is the concentration of mass over the given volume? For this case, if our mass is 1 kilogram and our volume is actually 1 meters cube, then we end up with 1 kilogram per meters cube. A few examples here will help us to understand density better. Number one, we have a question which says that a student measures the mass of an 8 centimeters cube block of brown sugar to be 12.9 grams. What is the density of the brown sugar? Now, to solve this, we need to use the formula. Density is equal to mass over volume, and the density there is actually going to be, to do this, we need to use the formula density is equal to mass over volume, so that our mass, which is 12.9 grams, we divide by 8 centimeters cubed, and the result will be, if you use your calculator, you get 1.6125 grams per centimeters cube. Another example for us is calculate the volume of a liquid with density 5.45 grams per milliliter and a mass of 65 grams. We have to calculate the volume of a liquid whose density is 5.45 grams per milliliter and has a mass of 65 grams. Now again, to do this, we need to remind ourselves of the formula. Density is equal to mass over volume. You've seen me use this symbol. Maybe we need to mention that this is actually a Greek letter rho, which is the symbol commonly used for density at this level. So density is equal to mass over volume, and I've introduced something here, a triangle, that we call the formula triangle. So using the formula triangle, we can see that if we have density here and volume here and mass at this point, you use these lines to see that if I am looking for density, I'm basically saying that density is equal to mass over volume. Volume is equal to mass over density. If I'm looking for mass, then I'm saying mass is equal to volume times density. Now, on the horizontal part, we can as well put a multiplication sign here, so that you can say that mass is equal to density times volume. And so, density is equal to mass divided by volume. Volume is equal to mass divided by density. That's the formula we are using here to get volume is equal to mass over density. And so that gives us 65 grams from the equation, 65 grams divided by the density, which is 5.45 grams per milliliter. When we use our calculator, we solve that and the result will be 11.93 milliliters. Thank you for watching this video to the end. Please subscribe for more videos like this and kindly like my channel. I'll be posting a lot of videos in physics, and